Welcome back to Exposure Stories. Did you know the highest price ever paid for a single diamond exceeded $71 million? With that amount of money, you could buy more than 14 Rolls-Royce Phantoms, a luxury car that only the ultra-wealthy usually dream of owning. Yet what makes a diamond a symbol of eternity is not simply its staggering price tag. Diamonds possess a unique crystal structure and near unbreakable hardness that make them among the toughest natural materials on Earth. More importantly, they are ancient beyond comprehension, formed billions of years ago deep underground under some of the most extreme conditions nature can create. From raw rock pulled out of the Earth's depths, each diamond undergoes an intense transformation, crushed, filtered, sorted, cut, and polished with almost unbelievable precision. Every stone must pass strict quality checks before it ever becomes a piece of jewelry or finds a role in high-tech industries. In this journey, we explore how an ordinary carbon atom becomes either the sparkling gem on a finger or a record-breaking centerpiece at the world's most exclusive auctions. The story of a diamond is remarkable not only because of its violent birth deep beneath the Earth's surface, but also because of how humanity has assigned meanings to it far beyond material value. A major turning point came in 1947, when the De Beers Company launched its now iconic slogan, "A diamond is forever." That single advertising campaign did more than sell gemstones, it reshaped global culture. It cemented the idea that a diamond ring was the ultimate symbol of love and commitment, transforming marriage traditions worldwide and embedding diamonds deeply into popular culture for generations. Some luxury wedding ring brands even went so far as to introduce a policy allowing each customer to buy only one engagement ring in their lifetime, reinforcing the idea that love, like a diamond, should be singular and eternal. Today, the meaning of diamonds continues to evolve through technology. Diamonds are no longer limited to those mined from the earth. Advances in science have made it possible to grow diamonds from the ashes of loved ones who have passed away. Companies such as Alga Adanza in Switzerland use HPHT, or high-pressure, high-temperature technology, to transform carbon extracted from cremated remains into memorial diamonds. For many people, this represents a deeply emotional way to preserve memory, blending science and human emotion into one of the most powerful symbols nature can offer. Despite their familiar sparkle, diamonds originate in environments so extreme they are difficult to imagine. Deep within the Earth's mantle, temperatures can reach up to 1,000 degrees Celsius, while pressures exceed 50,000 atmospheres. Under these conditions, carbon atoms, one of the most common elements on Earth, are compressed so intensely that their atomic structure rearranges completely. The result is a rigid, stable crystal lattice that forms a diamond. If even one of these conditions is slightly altered, the carbon does not become diamond at all but instead turns into graphite, the soft material found in pencil cores. Because this precise balance of pressure and heat is so rare, diamonds exist only in the deepest, oldest, and most stable regions of the planet. After forming and remaining buried for millions or even billions of years, a small number of diamonds are carried closer to the surface by ancient volcanic eruptions. They travel upward through vertical magma channels and become trapped in a rare volcanic rock known as kimberlite. This is where the human search begins. Many of the diamonds mined today were formed between 1 and 3 billion years ago, now lying hidden beneath the ground, waiting to be discovered. The process of bringing diamonds from deep within the Earth to the surface begins with exploration. Geologists use satellite imagery to detect unusual surface patterns, gravity sensors to identify density shifts underground, and magnetometers to locate magnetic anomalies that may indicate hidden kimberlite pipes. Sometimes, the discovery of even a tiny fragment of kimberlite mixed into surface gravel is enough to justify a full geological survey of an entire region. At major open-pit mining sites, enormous spiral-shaped excavations are carved into the earth, some stretching more than a kilometer wide and nearly 500 meters deep. Before each blasting cycle, dozens of powerful drills bore deep holes into the rock to place explosives. Once detonated, massive chunks of shattered rock are loaded into ultra-heavy dump trucks and transported for processing. In regions where deposits lie too deep or terrain makes open-pit mining impossible, underground mining is used instead. Workers descend through narrow tunnels that can extend 800 meters below ground, where conditions are hot, humid, dimly lit, and extremely dangerous, requiring strict safety measures. All of this effort is driven by the pursuit of something astonishingly rare. On average, around 250 tons of rock must be processed to extract a single carat of diamond, a stone barely larger than the tip of a pencil. Once the blasted rock reaches the surface, material believed to contain diamonds is sent directly into crushing systems. Giant machines weighing tens of tons operate like steel jaws, breaking down even the hardest rock. Yet despite their legendary hardness, diamonds are surprisingly brittle. A single poorly directed blow can shatter them into fragments, destroying their value. For this reason, crushing forces must be carefully calibrated, strong enough to break surrounding rock but gentle enough to preserve the hidden crystals. After crushing, the material enters the cleaning phase. Crushed ore is often mixed with clay, mud, dust, and sticky natural substances that can interfere with separation equipment. Industrial-scale washing systems use rotating drums, vibrating screens, and high-pressure water jets to remove contaminants. Particles smaller than 1 millimeter are filtered out, as the chance of them containing diamonds is extremely low compared to the cost of further processing. What remains is a concentrated ore, far more likely to hold diamonds. This is where advanced separation technology takes over. X-ray fluorescence scanners analyze material streams in real time, detecting the unique glow diamonds emit when exposed to X-rays. The instant a diamond is identified, a precise burst of compressed air ejects it from the flow. This process allows diamonds to be recovered with remarkable speed and accuracy, ensuring minimal waste and maximum efficiency. Once separated, rough diamonds enter preliminary sorting. Experts assess each stone based on size, color, clarity, and natural shape, while modern scanners assist in this process. Much still depends on the trained eyes of experienced professionals who can detect microscopic fractures or subtle color variations machines might miss. At this stage, diamonds are divided into two main groups: those suitable for jewelry and those destined for industrial use, such as drill bits, cutting tools, and high-performance components. Jewelry-grade diamonds undergo detailed analysis to determine how they should be cut. Every diamond is unique, so specialists perform full 3D scans to map internal flaws and light behavior. Software calculates cutting strategies that balance brilliance, symmetry, color, and weight. Some stones are split into multiple gems to maximize value, while rare, exceptionally clear diamonds may be left intact to create one-of-a-kind masterpieces. Cutting and polishing is one of the most delicate stages in a diamond's journey. Lasers make the initial cuts with microscopic precision, followed by grinding and polishing using wheels coated in diamond dust. The cutter carefully controls pressure and angles to shape each facet perfectly. This process can take anywhere from 3 to 8 weeks, resulting in a stone engineered to reflect light with breathtaking intensity. After polishing, diamonds are sent to grading laboratories where they are examined under powerful microscopes. Institutions such as the Gemological Institute of America and the International Gemological Institute evaluate each stone and issue certification documents that serve as the diamond's passport, verifying authenticity and quality. Approved diamonds then move to jewelry workshops, where master craftsmen set them into rings, necklaces, or earrings for iconic brands like Cartier, Tiffany & Co., and Harry Winston. Yet not every diamond has a flawless story. In some regions of Africa, diamonds are still mined by hand under harsh conditions. In places like Sierra Leone and Angola, miners work in muddy streams with little protection, often earning almost nothing. In certain areas, diamonds have funded armed conflicts, earning the name blood diamonds. These hidden stories remind us that behind a diamond's beauty can lie suffering and injustice. Diamonds are more than precious stones. They are the result of immense time, extreme pressure, and human effort. Understanding their full journey allows us to appreciate them not only for their brilliance, but also with greater awareness of the choices we make. If you found this journey insightful, remember to like, comment, and subscribe for more fascinating stories behind everyday objects that are far more extraordinary than they seem.